Welcome to a lesson with Dr. Powell. Let's take a look at how we can show that a proposition is true based on some other information. So let's suppose that we know that this conditional statement is true. So we're going to assume this is true, and we're also going to assume that this one is true as well. Okay, so basically this means right here, if this is true, then B and P have the options of either B is false or P is true, basically. So this arrow works, this arrow works, and see also this arrow works. All right. So assuming that this statement is true, this conditional if B then P, and this conditional is true, if not B, then B and A is true. How can we show that these ideas will force P being true? We think about everything in a Boolean algebra sense as a post set with arrows and different things. Just saying that one of these, that this conditional is true, kind of makes it so we can think about these things as being like subsets and like a power set structure, like set containment. So like B is like a subset of P. We know that. We also know that not B will be a subset of B and A. But, okay, but we also know, so if you throw, we don't know this arrow quite yet, but let's think about that for a second. So right now, maybe this is all we have, right, from these conditions. But we're going to be throwing these arrows in, and that's actually going to show us that P is true. So how do we throw those arrows in? Well, let's do it one at a time. Okay, well, let's think about this. So B and A, that's like B intersect A. That's like a subset of B. So naturally, of course, there's going to be an arrow going right here. Okay. Okay, so we know we have that. We know this is a post set, so that we have transitivity. So we have, if we have a path here, there's a direct path. Okay, that'll give us this arrow. All right. Then we have not B is below B. So what does that tell us? Well, I mean, these guys can't both be true. So they can't both be ones, and they can't both be zeros. So it has to be 1 or 0 or 0, 1. And there's only one way, and this is a true arrow in here. And so the one thing it can't do, it can't go 1. This is not allowed. So there's only one option, which means that we actually have determined what both of these guys are, meaning that we know that B is true. Wait a minute. If we know that B is true, then since B lies below P, that forces P to be true. Okay, so we've just done it. Thanks for watching.